We're going to spend the rest of our module on transition matrices. So first of all, transition matrices and then steady state. So what is a transition matrix? Well, it's called a transition matrix because it represents sort of a bunch of events consecutively happening, so after each other, that a certain transition is occurring, and it will sort of change again and again and again. So we'll have this transition happen multiple times. So in general, we call a transition matrix T, so that's another letter to stick away from in general. So remember we said that X was the XY matrix, so we thought we'd stick away from that. I was the identity matrix, we generally wouldn't use the letter I. T, I probably would reserve myself from using the letter T as well, because that generally is a transition matrix. So like we've always had in any table, the IV goes along the top, that's these horizontal variables, and the DV goes down the side, that's the vertical variables. So that was the same in core. It's pretty much always going to be the same. IV is this horizontal thing, and DV is the vertical thing, independent and dependent. So again, in a bigger table, IV here, DV here. So transition matrices are always square matrices. So you could have a 4x4, a 3x3, a 2x2. I guess you could have a 1x1, but it's pretty redundant. So they're used to represent a relationship between some different points. So for example, if we have three different locations, you can see here for location A, let's follow the arrows, 85% of people that start at A, or things, are ending up at B, and then the other 15% are going to C. So they're all going away from A. The things that start at B, 45% are going towards A, 30% are going back to B, and then 25% are going over to C. So similarly, with C, 10% are going to A, 20% are going back to C where they started, and then 70% are going across to B. So whether or not you understand that, let's represent that as a matrix. So the IV is like the first thing. Remember, the independent starts off. That's where we're coming from, and then the DV is where we're going to, the dependent variable. And that kind of fits with the IV-DV logic. This is the thing that begins, and this depends on where it comes from. So from A to A, let's look at our transition map over here. This is actually called a network map. Nothing is going from A to A, so we put 0. And then from A over to B, follow this arrow here, 85% of things are going from A to B. So that's like, as a decimal, 0.85. That's 85%. And it makes sense that the other 15% is going to C, but let's double check. From A to C, there's 15%. So all of these have to add up to 100%, or the number 1. So 0.85 plus 0 plus 0.15, that's 1, or it represents 100% as a percentage. And they should all sum up to 100% individually. So from B, there is 45% that go to A, 0.45. There are 30% that go back to B, and then from B to C, there should be 25%. B across to C, there's my 25% going from B to C, so 0.25. We can check 0.45 plus 0.3 plus 0.25, pop that in the calculator, equals 1, so 100%. And same thing, from C to A, C across to A there's 10%, C across to B is 70%, and then C back to C, there's 20%. And again, 0.1 plus 0.7 plus 0.2, that equals 1, or 100%. This is a kind of thing that we'll have to do a lot, particularly in multiple choice, recognising this map making this matrix, or we might have to set them up if we're doing a short answer question. So that's something that we'll get practiced a lot at in the textbook. After that, let me give you an example of a practical situation in which this transition matrix might occur. So Adam Scott, he's a famous golfer, if you didn't know. He's an Australian golfer. He won the Masters a couple of years ago, the US Masters. That was a pretty exciting event. Anyway, Adam Scott is playing in the US Masters golf tournament. He plans to play next year as well. So that's our transition, like there's a next year and this year. A betting company suggests the following chances. The chances that he will win this year, so Adam Scott's going to win the tournament, and win next year, is 67% chance. So we're talking about whether he wins or loses. So in terms of filling that in the matrix, you can see there's, like, we won't look at the answers just yet, but this year and then next year is our transition matrix. So our independent and our dependent, the from and to, from this year to next year. So this is winning this year and winning next year. This is winning this year and losing next year. Losing this year and winning next year, that's this one. and then this one losing this year and losing next year. So the chances, and this is the information we're given, he'll win this year and win next year is 67%. So win, 67%. And the chances he'll win this year and lose next year, 33%. Like, that makes sense. If he's going to win this year, there's a 100% chance he's either going to win or lose next year. Like, they add up to 100%. So here we go. Win and then lose is 33%. So he's going to, what's the chances he'll lose this year and then win next year is 85%. Lose this year and win next year, 85%. And it makes sense that there's 15% left. Losing this year and losing next year is 15%. So that's here. So just to sort of stand back in case you didn't get that 100% thing, if he's going to win this year, that's these first two, then obviously he's either going to win or lose next year. There's a 100% chance he's either going to win or lose next year. So these two, if he wins, should add up to 100. Also, if he loses this year, there's a 100% chance he's either got to win or lose. There's a 100% chance he's going to win or lose next year. So this win and lose here for next year should add up to 100 as well. Yeah, but I think that makes logical sense. So draw this situation as a transition matrix. So T equals, set up my this year, next year, set up my wins and losses, and there's my 4 different ones there. Often in practical situations like this, wins, loses, we'll get a 2 by 2 matrix. Often, like you saw just before, this sort of situation, you'll either get 2 letters and it'll be a 2 by 2, or 3 letters, it'll be a 3 by 3, 4 letters, a 4 by 4. I haven't seen it any more complicated than 3 in a long while. Generally 3 is the maximum we go up to, because it takes too much time in the exam to ask a question otherwise. That's all you've got to know in terms of how to set up a transition matrix.